This is the third and final section of Chapter 4, Flows in Networks 2, and this section is about restricted capacity nodes. So first of all, a restricted capacity node is a node which has a temporary or permanent restriction to its flow. So let's say we had this node B in a network and it had a restriction of 16 to its flow. So we would draw it like this. So we need to sort of extend this so we show what's going into node B and out of node B. We write down a restriction here. If we've got a minimum capacity, we could write it like this. Okay, so it just gets split up into these like two sub-nodes. And just a couple of other things to do with restricted capacity nodes. And those are that they can be included in cuts if you're trying to find the minimum cut, maximum capacity, and if the capacity of a node is reduced to 0, then it can be completely removed from the network. Example 8. The diagram shows part of a capacitated directed network. Node C has a restricted capacity of 41. Show this information on the diagram. Okay, so what I need to do is C is going to be split to C in and C out. Along that arc, I'm going to put this restriction, which is 41, and then complete the rest of the diagram. So I have 30 here, 24 here, and coming out 35 and 22. Example 9. The diagram shows part of a capacitated directed network. The node C has a restricted capacity of 15. Show this on the diagram. So you'll notice here that I have arcs which have a minimum capacity. So that will just change slightly the way that I'm going to show the information on the diagram, that restriction for C. So we have 512 here, 610, and then on the other side 710 and 514. 514, need to learn how to read and write numbers. And so we'll have C in and C out. The restriction is 15. But since we have minimum capacities, we write that as 0, 15. Example 10. Here is the diagram used in example 7. So you can see it here with the minimum maximum capacity for each of the arcs. It says the node B now has restricted capacity of 30. So I'm now going to show it on the diagram here. So here's my amended network. Now part A says explain why the maximum flow in a network cannot exceed 58. Now really to do that I want the minimum cut, and I can't really do the minimum cut until I know which of these arcs here are going to be saturated. Since this is restricted to 30, it's going to affect the flow along each one of these arcs, so I can't use it in its current form to work out the minimum cut. So I'm actually going to do part B first, and then when I've got part B, the answer to part B, I can then find a minimum cut to show that that's the maximum flow in that network. And part B, show a feasible flow of 38 for the new network. So I've got this restriction here. I'm not going to draw the B in and B out again, but just what we know is that is the restriction of 30. Right, I've also added onto this diagram the minimum and maximum capacity of each of the arcs and those arcs here which are saturated. So since I can only have a maximum of 30 going through B, I can only have a maximum of 30 going in to B. So that means that these two arcs, S2B and S1B, need to be at their minimums here. You can see them there, 20 and 10 to make the 30. So that means I will change this 21 here to 20, and this 16 here to 10. They have to be at their minimum so that I'm only allowing 30 through B. Okay, so now let's go back and see what impact that has on the nodes and arcs previously. So S2 now has 10 and 12 coming out, so that's 22. So I can only have 22 going in, so that means that I need to reduce this to 22, which I can do, it's above its minimum. And then if I look here, I've got 15 and 20 coming out. At the moment I've got 36 coming in. That's not a problem. I can increase this flow here by 1 up to its maximum 16 and saturate it. So make that 16, which means that arc S1A now becomes saturated. So I now have 36 coming out and 36 going in. That's fine. I can have that. So let's just, right there, I've got 36 there. So working our way across, I've got 16 going into A. I've got 7 here that's saturated. I can't increase that by more. So if I want to keep this as 16 coming out, this needs to be increased to 9, which is fine. I can do that because its maximum is 10. So I'll change that to 9. So if I now look at vertex D, I have 30 and 9. I've got 39 going into D. I need 39 coming out of D. I've currently got 45, so I need to reduce these down to 39. So one way of doing that is keeping this at 22. So 22, let's just highlight that. We'll keep that at 22. We'll keep that saturated, and we'll need to reduce this down by 6 because you want to go from 45 down to 39. So I can reduce this to 17. That's fine because that's above the minimum. So we'll change that to 17. So now we've got 39 going in, 39 coming out. We kept this one at the bottom saturated at 12. So that means going into E, I now have 17 plus 12, which is 29. That means I need to reduce what comes out to 29, which I can do. It's currently 35. So I'll move that down to 29. It's above its minimum. Going back up here to vertex C, I've got 7 and 22 going in, so I've got 29 going in, and I've actually got 29 coming out, so I don't need to adjust these. I can keep them as they are. Then looking at vertex F, I've got 21 coming in, 19 and 2 going out. That's fine. Conservation condition met there. Then going into T2, 29 and 2, which is 31. So this needs to be reduced to 31, which I can do. It's above the minimum. And then going up to T1, 18 plus 9 is 27, so that's fine. This can remain unchanged. And that gives me the 58. So let me just remove the bits we're not interested in. And it's basically just the numbers which are in the red circles there. So here's our completed feasible flow of 58 for the network. It's in 58 here, and we can see 58 here. So now moving back to part A, explain why the minimum flow in a network can exceed 58. The first thing I want to do is to identify all of the saturated arcs. Now these are all my saturated arcs. Now this one is saturated because remember B is restricted, and it's going to look something like this, where we have B in and B out, and what we're going to have is 0, 30, a minimum capacity of 0, a maximum of 30. So that makes this part here almost like saturated because of this restriction. So that allows me to find this cut along here like this. So the minimum cut is 16 plus 30 plus 12, which is 58. So by the minimum cut max flow theorem, 58 is the maximal flow. So this answers part A. So you should now be able to do exercise 4C on pages 130 to 132 of the textbook.